Okay. So today is day 13 of this series where I'm streaming every day until I get a job. And today is day 13, and today we have passed our first checkpoint. So basically इस stream में अब तक um, so this is going to be a stream जहाँ पे मैं figure out करूँगा कि आगे क्या करना है और अब तक क्या किया हमने. तो what I did was basically let's see मैंने क्या क्या किया है पिछले 13 days में. So specifically, what I wanted to do is कि सारे का सारा डी ऐसे रिवाइज कर लूँ फर्स्ट थिंग्स फर्स्ट. तो आई फील कि मैंने सारा डी ऐसे रिवाइज कर लिया है, सारे टॉपिक्स रिवाइज कर लिए एक एक करके. मैंने पूरा जो शीट थी उससे रिवाइज कर लिया. देन मैंने ये ग्राइंड 127 में से 105 प्रॉब्लम सॉल्व कर ली. तो आई काइंड ऑफ फील दैट आई एम एट अ पॉइंट जहाँ पे I have solved a lot of problems and revised a lot of and I've revised a lot of sheets. तो अभी I feel revision part is done. Now this is where I would start doing something else. ठीक है. तो उसके लिए I'm going to make a plan कि अब से हमें क्या करना है. हो चुका रिवीजन, हो चुका क्वेश्चंस फर्स्ट टाइम लगाने थे, हो चुके. अब कुछ नया करना है. ठीक है. बिकॉज हम इसी तरीके से करते रहेंगे तो कुछ याद नहीं रहेगा ना. और essentially what I feel is कि for example there are like कितने ही problems हैं, अगर honestly देखें तो we have around 300 400 problems at max. ठीक है. जो उन्हीं में से इधर उधर करके क्वेश्चन आ सकता है या फिर वो ही आ जाते हैं कोडिंग राउंड्स में और उसमें. एंड मैंने 260 लीड कोड पे सॉल्व करे हैं, ढेर सारे गीक्स फॉर गीक्स पे भी करे हैं, आई गेस थोड़े बहुत तो करे होंगे. तो क्वेश्चंस, एक सेकंड, कौन है? हाँ, कौन है? एक सेकंड. ओके, मुझे एक सेकंड लगेगा. ओके, सॉरी फॉर द डिस्टर्बेंस. तो द थिंग इज मेरा कोई पार्सल आया है G5 हॉस्टल में, मुझे वहाँ से लेने जाना है. बट ठीक है, वो हम बाद में ले आएंगे. तो मैं क्या कह रहा था, हाँ मैंने यहाँ पे कितने क्वेश्चन सॉल्व करे हैं. अराउंड लेट्स से दिस इज 100 क्वेश्चंस एंड दिस इज 260. तो मोर देन 350 क्वेश्चंस हम सॉल्व कर चुके हैं. ठीक है. मोर देन 350 क्वेश्चंस हम सॉल्व कर चुके हैं, विच मीन्स कि क्वेश्चंस तो हमने काफ़ी सारे सॉल्व कर लिए हैं. नाउ अब हम इसी तरीके से करते रहेंगे तो कुछ नहीं होगा. लेट्स ट्राई एंड डू समथिंग एल्स नाउ. अब क्या करेंगे हम थोड़ा, अब हम पर्टिकुलरली ऑर्गेनाइजेशंस को टारगेट कर करके उनके क्वेश्चंस प्रैक्टिस करते हैं. तो मुझे दो चीज़ों पे फोकस करना है. एक कंपनी वाइज, ओके व्हाई एम आई नॉट एबल टू टाइप एनीथिंग. कंपनी वाइज प्रॉब्लम सॉल्व करनी है मेरे को. दूसरा इंटरव्यू प्रैक्टिस करनी है मेरे को. अदर देन दैट आई डोंट थिंक देयर इज एनीथिंग एल्स, इज देयर? So let's say coding round practice, coding virtual coding rounds. Right, I can do virtual coding rounds. Maybe that's all I need to do now. These are the three main important things जो कि मैं target कर रहा हूँ. अभी हम second checkpoint पे आ गए. Let me write this here. Checkpoint number 2. So this is second checkpoint basically. फर्स्ट चेक पॉइंट में प्रैक्टिस थी, वो हो चुकी. आज 16th of August है. I have I don't know, maybe at least 10-15 days until actual में placement season शुरू होगा. तो तब तक I want to be ready. Okay. तो उससे हम करेंगे क्या, उसके लिए कुछ रिसोर्सेस मैंने इधर उधर से लगा के रखे हुए थे. आई डोंट नो अगर वो इतने काम के हैं या नहीं, चलो अभी चेक कर लेते हैं. तो कुछ पोस्ट मैंने सेव कर रखे हैं. फॉर एग्जांपल saved post में I guess I have a post. mm, this one, yep. इस पोस्ट में ढेर सारी लिस्ट वेस्ट कुछ तो है ऐसा। लेट्स सी क्या क्या है। आई मोस्टली फाउंड रैंडम लिस्ट ऑनलाइन। ये देखो, गूगल और फेसबुक और इंटरव्यू क्वेश्चंस। गूगल के इंटरव्यू क्वेश्चंस, फेसबुक के। अच्छा, दिस इज गूगल इंटरव्यू क्वेश्चंस एज लीड कोड लिस्ट। ये रहे, ये गूगल की 30 प्रॉब्लम्स है। देन देयर आर प्रीमियम क्वेश्चंस जो कि मैं नहीं कर सकता। अदर्स मैक्स 3 ऑन साइट्स ओनली। आई डोंट नो व्हाट दैट मीन्स। देन देयर आर अनदर गूगल के लिस्ट की प्रॉब्लम्स। इसमें 30 थे और इसमें भी अराउंड 80 प्रॉब्लम्स है। ठीक है। देन वी ऑल्सो हैव हैज ऑल क्वेश्चन फॉर प्रैक्टिसिंग गूगल का ऑनलाइन असेसमेंट 2021, उससे रिलेटेड प्रॉब्लम्स 22। ठीक है। डोमेन स्पेसिफिक अभी लाइट लेते हैं। ठीक है। ये क्या है? लीड कोड स्लैश इंटरव्यू। यहाँ पे क्या होता है अभी चेक करना पड़ेगा। दिस इज, अच्छा, ये मेरे काम का नहीं। अभी फेसबुक के प्रॉब्लम्स हैं। चलो हम फेसबुक के प्रॉब्लम्स नहीं कर रहे सॉल्व, पर्टिकुलरली बिकॉज आई डोंट नो फेसबुक में मैं जानना भी चाहता हूँ या नहीं। तो फेसबुक को लाइट लेते हैं। उसके अलावा क्या है? फेसबुक के प्रॉब्लम्स तो बहुत सारे हैं। सॉफ्टवेयर इंजीनियरिंग के लिए पिछले 1 साल के सारे क्वेश्चंस। कितने हैं? 100 क्वेश्चंस हैं। मोस्टली मैं कर चुका हूँ तो इतने नहीं है। ठीक है। ये 20 हैं। ये गूगल पार्ट 1, ये गूगल पार्ट 2, ये गूगल पार्ट 1 80 से, और ये गूगल पार्ट 2। एंड देन ये ओपन असेसमेंट है गूगल का। एंड देन ये फेसबुक के 1 साल के प्रॉब्लम्स हैं। ठीक है। इसके अलावा और क्या है? एक और है लिस्ट जिसमें लेट्स ट्राई अमेज़न का। कहीं पे है क्या? अमेज़न। अमेज़न, क्योंकि पॉसिबिलिटी है कि मेरे को अमेज़न का टेस्ट देने का मिलेगा। तो ये 50 प्रॉब्लम्स अमेज़न के हैं। देन आई डोंट नो लिंक्डइन कितना पे करती है बट लेट्स ट्राई। लिंक्डइन के प्रॉब्लम्स में ऐसा कुछ इंटरेस्टिंग नहीं होगा, आई डाउट, बिकॉज वो ऑलरेडी आई एम अज्यूमिंग कि वो कवर हो चुके होंगे। ये टॉप 50 गूगल के क्वेश्चंस और हैं जो कि यहाँ पे लगा देते हैं अमेज़न के बाद। तो अभी के लिए मेरे को ना अमेज़न गूगल को टारगेट कर सकते हैं। बाकी अमेज़न का ठीक है, ज़्यादा लग रहा है मेरे को चांसेस कि मैं अमेज़न में अटेम्प्ट कर सकता हूँ। गूगल का आई एम नॉट रियली श्योर अबाउट इट, बट ठीक है। तो एक प्लानिंग करते हैं। मेरे को पता है कि अमेज़न के 50 क्वेश्चंस हैं। ये मेरे 50 क्वेश्चंस हैं। ठीक है। ये मेरे को अटेम्प्ट करने का है। तो ये मेरी लिस्ट क्लोन हो गई सबसे पहले एज एज आई टोल्ड यू कि मैं 27 क्वेश्चंस और 22 ऑलरेडी कर चुका हूँ इनमें से। तो जो नहीं करें वो कर लेंगे, और जो करें एक बार उनको पढ़ के देख लेंगे। ठीक है। इट्स नॉट दैट टफ। चलो इसको सेव कर लेते हैं। अमेज़न प्रॉब्लम्स। ठीक है। तो ये अमेज़न की प्रॉब्लम्स होगी जो कि सबसे पहले मैं सोच रहा हूँ अमेज़न की प्रॉब्लम्स लगाने का, क्योंकि वो मेरे को पसंद है। दैन गूगल की 50 प्रॉब्लम्स कर सकते हैं हम। क्लोन कर लेता हूँ एक बार। लेट्स से इसमें से कितनी, इसमें से कम करी होंगी आए, या सिर्फ 7 ही करी, क्योंकि देख के ही लग रहा था। गूगल 50। ठीक है। गूगल 50 में से थोड़ी कम करी है, बट हम कर लेंगे, कोई ना। बाकी देन दिस इज गूगल 2020 पार्ट 1। इसमें से काफ़ी करी है, 23 करी है, नहीं ज़्यादा नहीं करी है। तो गूगल लिस्ट 1, आई डोंट नो अगर मैं गूगल लिस्ट 1 करूँगा भी या नहीं, बट ठीक है अभी के लिए गूगल लिस्ट पार्ट 2। चलो इसके बारे में देखें तो दिस इज पार्ट 2। इसमें से सिर्फ 6 प्रॉब्लम्स करी हैं। लिस्ट 1 and 2, ठीक है। इसके बाद हमारा फाइनली वी हैव गूगल ओपन असेसमेंट। चलो ये ज़रूर करेंगे क्योंकि ओपन असेसमेंट का मेरे को थोड़ा डर लगता है वैसे भी। ओपन असेसमेंट नहीं होते यूजुअली, ये भी कर लेंगे। एंड देन वी आल्सो हैव फाइनली फेसबुक का जो 2020 से 2021 तक रहा है उसके प्रॉब्लम्स है। तो डैम, आई सॉल्व्ड अ लॉट ऑफ प्रॉब्लम्स यहाँ पे, विच इज़ फाइन। एफ बी ओके, काम करते हैं, ऑर्डरिंग ऐसे रखते हैं, मेरे को इस ऑर्डर में क्वेश्चंस करने हैं, ठीक है। पहले अमेजोन की प्रॉब्लम्स करेंगे, फिर गूगल की 50, फिर गूगल के ओपन असेसमेंट, देन गूगल की लिस्ट 1 and 2, देन फेसबुक इफ द टाइम परमिट्स। आई डोंट थिंक मैं यहाँ तक जाऊँगा, यहाँ तक नहीं जाऊँगा। मोस्ट प्रोबेबली मैं ये 3 सेक्शंस पे फोकस करना चाह रहा हूँ पर्सनली। उसके बाद लेट्स सी कि क्या होता है। आई हाईली डाउट अगर मैं वहाँ तक जाऊँगा। ये कितना गंदा कलर है भाई, लेट्स चेंज द कलर, ठीक है। डजंट लुक ऑफुल, तो ठीक है। ऑल्सो इसमें टेक्स्ट कलर वाइट कर सकते हैं क्या? फिर दिखेगा नहीं कुछ अगर मैंने टेक्स्ट कलर वाइट किया, दिखेगा? दिखेगा अगर मैं यहाँ डार्क कलर कर दूँ एकदम, पर कितना गंदा लग रहा है। नहीं नहीं, हटाओ। ये भी हाईलाइट भी मेरे को अच्छा नहीं लग रहा है, ऐसे कौन हाईलाइट करता है भाई? और लाइट कलर, ठीक है, अभी ठीक है। मेनली लेट्स ट्राई टू डू दीज प्रॉब्लम्स फर्स्ट, ठीक है। तो ये मेरी माई लिस्ट बनी हुई है। तो सबसे पहले अमेजोन वाली करेंगे, तो अमेजोन वाली ओपन कर लेता हूँ मैं। इसमें सिर्फ 27 क्वेश्चन और करने हैं। ये रही लिस्ट हमारी, 27 क्वेश्चन ही हैं, ज़्यादा नहीं है, आराम से हो जाएंगे हमसे, ठीक है। इसके अलावा ये तो हो गया चलो क्वेश्चंस करने का, कहाँ से करने हैं, क्या करने कंपनी वाइज। पर मैं चाहता हूँ कि मैं इसको ऐसे डायरेक्टली ना करूँ। एक काम करते हैं, क्या मैं इन क्वेश्चंस में से रैंडम 3 क्वेश्चंस निकाल के, 3 क्वेश्चंस नहीं, 2 क्वेश्चंस, 1 घंटा दूंगा रैंडमली 2 क्वेश्चंस, ठीक है। और वो 2 प्रैक्टिस करने हैं, मेरे को ऐसे करना है। तो क्या ऐसा कोई पॉसिबिलिटी है? क्या ऐसा कोई पॉसिबिलिटी है जहाँ पे मैं रैंडमली 2 क्वेश्चंस कर सकूँ? ये तो मैंने एक कर लिया, इसके बाद ये कहाँ से पिक हो रही हैं? इन्हीं में से पिक हो रही हैं। अच्छा 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 अच्छा। फिल्टर में भी लगा सकते हैं हम कुछ, क्या लगा सकते हैं? फिल्टर कुछ लगाने ही नहीं है। तो ये ऐसे हो सकता है, ऐसे करके रैंडम करोगे तुम तो रैंडम रैंडम आ जाएगी, कोई दिक्कत नहीं है। ओह, ये मैंने करी है। ये सिंपल ग्राफ बीएफएस से बन जाता है। ग्राफ बना के बीएफएस लगा दो। अभी तो सबमिट नहीं किया मैंने, लेकिन इट्स पॉसिबल। अच्छा, मैंने अटेम्प्ट तो करा होगा, अटेम्प्ट ही नहीं करा। ऐसा कैसे हो सकता है कि मैंने अटेम्प्ट ही नहीं करा? कोई दूसरा क्वेश्चन होगा जो मैंने ट्राई किया है। एनीवेज, ठीक है, ये रैंडम हो रहा है, इस पे रैंडम हो रहा है, तो हम रैंडम ही ट्राई करेंगे। पर मेरे को ऐसा नहीं लग रहा कि ये, ऐसा क्यों लग रहा है कि कोई भी सॉल्व्ड प्रॉब्लम नहीं दिखा रहा? जो मैंने सॉल्व कर रखी है वो नहीं दिखा रहा है, मोस्ट प्रोबेबली ऐसा फील आ रहा है। इज इट दैट एक क्वेश्चन ऐसा आ जाए जो मैंने सॉल्व कर रखा हो, जैसे ये मोस्ट कॉमन वर्ड मैंने सॉल्व कर रखा है, सबमिशन नहीं है मेरा, व्हाट द हेल। आई यू श्योर कि ये इसका मैंने कोड लिखा है पर सबमिट नहीं किया है? ये कैसा कोड है? एक्सक्यूज मी, ये तो कुछ और ही है भाई, ये कौन लिखा है? हम्म। अच्छा, वर्ड ब्रेक आया था, अभी वर्ड ब्रेक आया था। ये भी आया देखो, मीडियन फ्रॉम अ डेटा स्ट्रीम, ये सबमिशन एक्सेप्टेड। तो सॉल्व वाले आ रहे हैं क्या पिक करने पे? ये मैंने सबमिट नहीं किया बट मेरे को पता है कैसे करना है। ये मेरे को नहीं पता कैसे करना है, ये भी मेरे को पता है कैसे करना है, ये सब मेरे को पता है कैसे करना है। ये वापस से वही आ गया, ये मैंने सबमिट नहीं किया, ऐसा कैसे हो सकता है? अच्छा, क्योंकि इसमें इसने वो पूछ लिया मेरे से, ठीक है इसलिए नहीं किया सबमिट। हाँ हाँ, इसमें इसने स्लाइटली अलग चीज़ पूछी थी मेरे से, तो बस इसीलिए नहीं किया। ठीक है, ऐसे रैंडम करके चल जाएगा क्या काम? चल ही जाएगा। मैं देख रहा हूँ कि सॉल्व्ड क्वेश्चंस नहीं आ रहे रैंडम करने के बाद, पता है। अच्छा लाइट लो, एक काम करो, हम खुद ही बना लेंगे, इतना भी मुश्किल नहीं है। मतलब कुछ बना नहीं रहे हम, बट मैं कह रहा हूँ कि हम खुद ही इसको ऊपर नीचे नहीं कर सकते, व्हाट द हेल। हाँ मैं कह रहा हूँ हम खुद ही चूज कर लेंगे कोई भी दो क्वेश्चन इसमें से, इसमें इतना मेहनत की बात नहीं है। ये सॉल्व्ड है, ये अटेम्प्टेड है, और ये टू डू है 27। ठीक है, हम खुद ही चूज कर लेंगे दो प्रॉब्लम रैंडमली, एंड वो दो प्रॉब्लम को हम फिर सॉल्व करेंगे 45 मिनट्स में, जैसे हम इंटरव्यू में। और अब से हम यही किया करेंगे, ठीक है। तो ये तो ऐसे करके टाइम फ्रेम बनाते हैं, चलो। तो यहाँ मेरे को 27 क्वेश्चंस लिखे हैं, तो मैं 30 क्वेश्चंस अज्यूम कर रहा हूँ कि मेरे को करने पड़ेंगे, ठीक है। फिर इसके बाद मैं सोच रहा हूँ कि मैं करूँगा गूगल के टॉप 50 क्वेश्चंस, इसमें से मेरे को 43 करने हैं, तो 70 क्वेश्चंस हो गए टोटल। एंड देन मेरे को करना है ये ओपन असेसमेंट, जिसमें से 18 ही करने हैं, तो 20 और जोड़ लेते हैं, तो अराउंड 90 प्रॉब्लम्स हो रहे हैं मेरे पास, ठीक है। 90 क्वेश्चंस हो रहे हैं, 90 क्वेश्चंस करने हैं मेरे को। आज 16th यानी 13th स्ट्रीम है, तो लेट्स से कि हम 7 दिन में ये सारी तीनों चीज़ें ख़त्म कर लेंगे। अच्छा 7 दिन बहुत ज़्यादा होते हैं 90 क्वेश्चन के लिए, तो मैं हर रोज़ 4 क्वेश्चन भी करूँगा तो बहुत स्लो हो जाएगा। 6 क्वेश्चन करूँगा 90 के लिए तो 15 दिन लगेंगे, हेल्प। 6 क्वेश्चन से 15 दिन लग रहे हैं, 10 क्वेश्चन से 9 दिन लग रहे हैं। हम्म, तब तो मेरे को बहुत क्वेश्चन करने पड़ेंगे। कितने करने पड़ेंगे? 12 क्वेश्चन करने पड़ेंगे हर दिन एटलीस्ट, तब 5 दिन में 60 होते हैं। मेरे को मैथ्स बहुत ख़राब है, कैलकुलेटर यूज़ करते हैं, चलो। 90 प्रॉब्लम्स करने हैं, और मेरे हर दिन 12 से ज़्यादा तो मैं कर ही नहीं सकता, मतलब 7 प्रॉब्लम करने हैं रोज। नहीं, 7-8 दिन लगेंगे अगर मैं 12 प्रॉब्लम करूँगा तो। ठीक है, तो होप करते हैं कि स्ट्रीम नंबर 20 का टारगेट लेते हैं, चेक पॉइंट 2, जब हम ये सारे 90 क्वेश्चन कर चुके होंगे, ठीक है। चलो, तो ये हो गया हमारे उसका। आज की शुरुआत ही कर देते हैं सिर्फ बिकॉज मेरे को कुछ और है नहीं करने को, तो चलो दो प्रॉब्लम्स अभी लेके ट्राई करते हैं, ठीक है। दो रैंडम प्रॉब्लम्स लेते हैं और उनको सॉल्व करते हैं, जो इसमें से। और अभी कोई बहाने वहाने नहीं, जो करने हैं तो करना ही पड़ेगा, चलो। एंड लेट्स ऑल्सो ट्राई टू टॉक कि कैसे वो प्रॉब्लम कर रहे हैं हम, ठीक है। 12 प्रॉब्लम्स बहुत होते हैं, कैसे करूँगा मैं? लेट्स गो। तो ऐसे दिस इज द फर्स्ट प्रॉब्लम एंड दिस इज द सेकंड प्रॉब्लम। वेरी इंटरेस्टिंग। सो उसको करने के लिए मेरे को सब्सक्रिप्शन मांग रहा है। और कोई है क्या जो बिना सब्सक्रिप्शन के हो जाएगा? ये सब तो सब्सक्रिप्शन। अरे ये मैंने जानबूझ के नहीं किया, अभी इस क्वेश्चन में कुछ है नहीं, तो मैं इसको क्यों करूं? समझ नहीं आ रहा मेरे को। अभी ऐसी सिचुएशन में मैं क्या करूंगा, जो मेरे को पता है कि इस क्वेश्चन में कुछ है नहीं, पर मैंने नहीं किया क्योंकि मुझे नहीं पसंद है, कोई सेंस नहीं था इसका। के क्लोजेस्ट पॉइंट निकालने हैं ओरिजिन से, अगर कुछ है नहीं तो सबमिट कर दो ना। सही बात है, कुछ है नहीं तो सबमिट कर दो। ओके, खुद ही करते हैं। Alright, so the question is that we have given an array of points where points of I represents the x and y coordinates in a form of array in integer k. Now I have to return the k closest points to the origin. So it's supposed to be a very straightforward question. I can just import heap q, and then what I can do is I can have my heap. So I have to find the k closest to the origin. So let's say I have this heap, which is an empty array right now. Now I'm gonna say for point in points, okay? For point in points, um, the first thing that I'm gonna do is I'm gonna say heap q dot heap push. Now I push something, which is I push a number. The number is gonna be dist, right? And then I'm gonna check if length of heap, if it is greater than k, then heap q dot heap pop heap, right? Let's put negative of dist, the distance between 2 points. You may return the answer in any order. You have to return k closest points. So let's say this is distance comma point. Okay, now it makes a lot of sense. So it also says what if, okay, so my question is if what will happen if 2 points are having the same distance from the origin. This is x square kept plus y square. If 2 points have the same distance from the origin, in that case, what will be your take? So there is nothing like that written in here. So I'm gonna assume that they don't really care about it anyhow. So that's fine. Now let's find out the distance. Well, the distance is simply going to be x comma y is our point. So this is gonna be x to the power of 2 plus y to the power of 2 raised to the power of 0.5, right? So this is that, and now let's say this is my answer array and I'm going to return an answer. Now what I'm going to do is I'm going to say while length of heap, while my heap is not empty, let's get top equals to heap q dot heap pop in heap. I don't know if that really returns anything or not in Python. So what I can do is answer dot append heap of 0 of 1. Let's run the code. It says heap q doesn't have any heap pop. Let's run the code once again. So yeah, the point is returned and the answer is correct. Let's try to do the same thing with 2 points. So now we want 2 points which are closest to the origin. Will this code work? I should also check okay, what code will work for all the test cases or not. But anyways, this worked. Now, next problem. Let's do pick one. So this is LFU cache. Okay, what's LFU cache? It is least frequently used. There is LRU, which is least recently used. Then there is LFU, which is least frequently used. So we have to implement a LFU cache class such that it is going to have a capacity. Then we say int get, which will get the value of key if the key exists in the cache. Void put updates the value of key if it's present, or insert the key if not already present. When the cache reaches its capacity, it should invalidate and remove the least frequently used key before inserting a new item. So now here we are trying to remove the least frequently used key. The key that has been least frequently used, which is least recently and least frequently. Isn't it the same thing? Or is it? So it says before inserting a new item, for this problem when there is a tie, the least recently used key would be invalidated. When there is a tie, two or more keys with the same frequency, the least recently used key would be invalidated. Oh, so this is about frequency, not about recent. Okay, so this is slightly different. To determine the least frequently used key, a use counter is maintained for each key in the cache. The key with the smallest use counter is the least frequently used key. When the key is first inserted into the cache, the use counter is set to 1. The use counter for a key in the cache is incremented either at a get or a put operation called on it. Everything should run on O of 1. So we need a doubly linked list to store the keys value thing so that we can remove them from the linked list or add them to the linked list in O of 1. Now the second thing that we would need is we need to maintain the order. So when we access something, we don't put it to the front. Instead, what we do is we increase its use count by 1. Now the question is, if the use count has increased, how will that affect other keys? And how will you do all of this in just O of 1? Okay, so let's think about it. Let's think about it. It doesn't tell you what companies have asked this question. Okay, key with the smallest use counter is the least frequently used key. So let me think for a minute, okay, and then I will try to solve it. Hmm, use count. So, okay, I think I have a solution. My solution is that I can use a doubly linked list and I can solve this problem the same way I solved LRU cache. So so in the LRU cache, what I had is I had left here and I had right. There is left and right in my doubly linked list, two nodes. Those are virtual nodes that I created for my easy access and stuff. Now, the question so in that case, what we did is basically we found the node and we used to say, okay, now this node is correct. So what you do is you take this node and you put it at the front. So you remove it from here. So you connect these things together so that it is removed from here. And then you take this and what you say is put this in between the um, right, like before the right. So you know what's right. So what you essentially do is you get right ka previous, which is this, and you say iska next is this, right? And you also say that iska next is this, and you say कि iska previous is this and iska previous is this, and this is how you have replaced it here. Now what you're gonna do is basically you don't really need right anymore. You just need left. Let's say I have left, so this is my theory, this is what I'm assuming, and you have these nodes with you 1 2 3 4, and this is like this has like I uh, this as the counter value and this has j as the counter value. Now if you access this particular node using get method once, then I'm going to increase the counter value by 1. So now the counter value is I plus 1. Now I'm going to check if the counter value has become greater than equal to to the counter value of the one that is in front of this particular node. And if that's the case, then I'm going to remove it from here and I'm going to append it here. So essentially my nodes will become 1, 2, 3, 1, 3, 2, 4, where these two are having the same frequency. This is having a higher frequency and this is having a lower frequency. So this is also taking care of that least recently used factor, because this is least recently used also if they have the same frequency, right? Similarly, the thing is, uh, yeah, so let's say you're adding something, so it's gonna delete this. Next, you're adding something, it's gonna delete this. If it has, uh, it's gonna delete this and then add something here. So let's try to let us try to simulate this problem for some test case. Okay, let's do that. So initially you created LFU cache with your uh, what with your you created LFU cache with your capacity as 2. Now you say you want to put 1, so you put 1 here. I'm gonna say this is my key 1 and the counter is also 1. Now you put 2, so you're putting 2 here and the counter is 1 once again. Okay, that this is your doubly linked list like this, and this is your left. I don't really know if you need left. Yeah, you need left because in case you want to delete something, you need left. Okay, so this is it. Now you say that you want to get 1. So you get 1. 1 is there, and now what you do is you check. You increase its counter, you say 2, and now 2 has become greater than equal to 1. So you take this one and you replace it with the 2. I mean, swap the values from the adjacent one. So now your doubly linked list will become left to 1, and this is having counter value 2, this is having counter value 1. Now you say you want to put 2 inside of this thing. So 2 was already here, and when you say put once again, no, you don't really put 2. Are you putting 2? No, you're putting 3. So yeah, you're putting 3. You're putting 3, and now I know that the next to left was remove this thing because the capacity has increased. So you remove this thing completely. And when you have removed this thing, your left is now attached to 1. And basically, you also need right, I guess. Definitely you will need right, otherwise it's not gonna work, because how will you append something? So yeah, you use the right node to insert the new thing into here. So now this has capacity, this has counter 2, this is 1. So this is not how it's supposed to be, right? So when you inserted it, counter of 1 was 2. So 2 is the LFU key, 2 is smallest, invalidate, cache 3 1. So this return 2 minus 1, return 3. Now the count has increased, but okay. So this is a problem. So this is problematic for me now. Problematic part is that when I'm inserting something, I cannot be inserting it at the end point. See, anything that is inside of the list will have count greater than equal to 1. So technically, what you should do is you should take this and you should append it right where the node having the count 1, last node having the count 1. You need to append it after that, right? So what do I mean by that is basically, let's say you have 1 2 3, and this is frequency 1, this is frequency 2, this is frequency 3. Now you append 4, so your 4 will also have frequency 1, right? Your 4 will have frequency 1. So ideally you need to append 4 here. This is 1 4 2 3. Why? Because if you append it at the start, then it is least recently used, but this is not the case. It is like most recently used. So there's something in my mind right now, which is How about I append it at the least recently used part, and then I check, and then I check what is the frequency of my write. Then I move it to the end. But what if everyone had frequency? I will insert it's gonna take O of n time. So this solution that I'm proposing, in the worst case, it's gonna create O of n time because it's going to go over all the nodes that were there with the frequency 1 in order to reach the end. I can maybe solve this problem if I keep one more variable, last one, something like last one frequency element, right? And then use that variable and append 4 right after that. Maybe that could be one possible solution. Then the time complexity would be O of 1 always. Okay, what should I do? Should I try and use the theory that I've thought and try to solve this problem? Probably. Um, okay, so let's just try and do it. Okay, so let's have a class list node, and let's say define init self comma key comma value comma count. Right, we're gonna say self dot key self dot value is value, count is count, self dot left, self dot next is none, self dot trail is none. Now when you are initializing something, you can say self dot capacity cap equals to capacity. You can also say that your self dot dll equals to, maybe you can say self dot left comma self dot right equals to list node. So you have two list nodes, list node of 0 comma 0 comma 0. You don't really care about the left and the right nodes as such. And you also have self dot h, which is a hash map, which is going to store some things for you. And maybe you can also have self dot last, maybe self dot pivot. Let's call it pivot. And initially it is none. Okay, these are all the things that I have to do. I wish. So there is more functions like remove. When you're trying to remove something, you're gonna say that I'm going to give you the node. So now prev comma next is node dot prev comma node dot next, right? How do you remove something? How do you remove a node from doubly linked list? Yeah, how do you remove a node from doubly linked list? You have 1, 2, 3, and you want to remove 2. So you have prev equals to 1, next equals to 3. You simply can do prev dot next equals to next. First thing is prev dot next equals to next, right? So 1 next is 3, and you can do um, next dot prev equals to next dot prev equals to prev, right? Next dot prev equals to prev, and this is how you remove the node in O of 1. Next thing that I want to do is I want to add something, right? I want to add a value or a node. Let's say I want to add a node. So when I'm adding a node, this is where I have to check certain things. So I'm gonna currently pass it because I don't know how to write this function essentially. So that's that. What else do we have? We have to write the get and put function, which are the main functions. Kwanit said yes, go ahead. Thanks. Check certain things. So I'm gonna currently pass it. Okay, yes, where were we? We are going to try and write the get functions first of all. Okay, so when we are going to write the get function is basically to get the key from this thing, right? Which is going to be slightly easy, is it? Now I have another problem. It's sort of like a problem, which is, let's say my list is like this, where I have the count equal in everything. Now, if I access this thing, now I will have to put it like I will have to move it n times, just not what I want. So this problem is not going to be solved so easily. I can solve LRU cache, but I cannot solve LFU cache in this way because it's gonna take off n time either way. It's not very helpful for me. Can I use something else in this particular problem? I want hints. Let's say, so it still says that I have to use the similar thing. Well, yes, you can solve LRU cache using a slightly similar method. Is it also in this? Yes, so LRU cache भी यहीं पे है. So how about I write code for LRU cache first because I know how to make it work. That's what I think. I mean, I'm trying to figure out how LRU cache would work. So let's also solve LRU cache. So this is fine, this is fine, this is fine. Removing is fine. Now I have to add a node into this LRU cache. So LRU cache is slightly simpler because when you're trying to add something in an existing node, in an existing doubly linked list, when you're gonna be adding something, it's gonna be slightly easier because वो सबसे it's gonna be used as the most recently used thing. So you can definitely go ahead and put it at the right. So your right is here. Now what you can do is you can put it near this. So you can get brave equals to self dot right dot brave, right? So this is the brave. What you can do is you can say brave dot next equals to node, right? Whatever the node you have, and you can say node dot brave equals to brave, and you can say node dot next equals to self dot right, and you can say self dot right equals to self dot right dot brave equals to node. And this is how you've added something at the back, and if this is how you removed something from the front. Now let's try and put something into the LRU cache. So when I'll be putting something into the LRU cache, I have a key and I have a value. Now I have to put this, or maybe let's first do get. So I want to get something from the LRU cache. So first thing I'm going to do is if key, the key that you have. So if that is in self.h.get key comma -1, if it comes out to be -1, which means the key is not here, in that case I'm going to return -1. Otherwise, if the key is inside of that thing, I'm trying to get it, and I'm saying that if the key is there, then the first thing that I'm going to do is I'm going to say self.remove. So if the key is there, then yes, this node is going to be self.h of key, right? And I'm going to say self.remove because I want to remove this node. Okay, so you've removed this node and you are going to add this node now. Self dot add this node. Okay, so that's all you're gonna do. And also you're gonna return the node dot. So do you want the values? Maybe. So you're gonna return the node dot value. Okay, that makes a lot of sense. Now in the put function, you are going to put a key into the thing. So once again, if self.h.get key comma -1, if it is -1, if it is not -1, sorry, if it is not -1, yeah. So if this thing is not -1, which means the key is already inside of the hash map, in that case, we are going to update the key self.h of key is now going to have a new value. Um, so no, that's not how you update. You say that node is gonna be self.h of key, and node dot value is going to be updated, and you're gonna remove the node, and you're going to add the node, right? And you don't really return anything, do you? You do you return anything when you add? No, you do not. Else, if it was not here, then you can simply add a node. So your node could be node list or list node key comma value, and you say self dot add node, right? So this is something that you can do. I really do not need count anymore. Let's try and fix our code if it has any problems or something like that. So it says that it takes three multiple arguments but only two given, or instead it takes only two arguments but four were given. Three arguments or four were given. An untype object has no attribute next. So it says you can get previous of this thing. Hmm. Uh, Maybe because I didn't do this. Next of Lex is right and brave of right is left. Now it says that it worked fine for some cases and then it started throwing errors. Because when you are adding something, you have to add it into the hash map also. Otherwise, it's not gonna work. Now it says that it's not working for some particular case. So when you're putting something, how about I print my hash map whenever I'm adding something? Not a great idea, but okay. So we kind of put, oh, I never took care of the capacity, that's why. Because when I'm putting something, I'm not taking care of capacity at all. Hmm, got it. So what do I have to do? When I'm adding something, I have to increase the count, maybe decrease the cap minus one, right? Decrease the cap by one. And if after adding something, I found if the self dot cap is negative, if it is negative, then you need to remove something. What do I need to remove? I need to remove the self dot left dot next, and I have to increase the capacity by 1, and I also have to delete the, when I remove something, I really do not return anything, but I can probably return the node. I do not need to return the node because the node is this one only. So delete self edge of this. It says that key error. You don't really have such key. Hmm. I still have the same error. Hmm. Maybe now the error won't be there. Yeah. LRU cache is comparatively simple. That's what I feel. But this LFU cache, this is something really interesting. चलो इसको दोबारा से ट्राई करते हैं. अब ये हम थोड़ा और ट्राई हार्ड करते हैं तो शायद हो जाए. Okay, let us remove this content from here. Okay, abhi let's again try to do LRU cache once again. That's what I feel. But this LFU cache, this is something really. So this we did, but now we're trying to do LFU cache. Okay. Hmm. Let's think about it. What can I do? Hmm. My only problem is arising when we have nodes of same counter value. Let's say each of these have counter value as 4. And this is right and this is left. Now the problem is if I let's say now I have counter value or not 4, let's assume that okay, will it happen if all of them have the counter value 4? Yes, and I access 1, then in that case the problem is that I need to put 1 at the end of this entire series which have the same counter values. Okay, I have another idea. How about if I use multiple doubly linked lists depending on the counter value? So if the counter value is 1, then I have a doubly linked list. If a counter value is 2, then I have a separate doubly linked list. And if I have counter value 3, then I have separate doubly linked list. पर इसमें प्रॉब्लम कहाँ आएगी? प्रॉब्लम आएगी when you search for a number, let's say 4. Now you know the node, but how about not only node, you also store the place where it is present. If it is present in the first one, second one, third one, and then the node also, right? Now in this problem, in this solution, uh, if you access the node inside of this 2, right? If you access the node inside of this 2, then you remove that node from this particular thing and you take that node to the next one, a higher level key, if that exists. If that doesn't exist, then you make one and you add it here and also update the things here. Similarly, if someone says that you have to put a new key, so you put it at the end of this one, right? And this is like an array. This could well be an array or whatever you want. It could be anything. Um, and you just extract the first one from here. It also has a capacity thing. So if the capacity, so once you have increased, then this is very simple. You just remove it from here and the capacity thing will always be maintained. Will it be though? I mean, it will always be maintained. Technically, it should always be maintained. What if you're putting a new thing? Then when you're putting a new thing, and if it doesn't really exist, if it exists, then you increase the count. But if it doesn't really exist, in that case, you can simply put it in the first bucket. Okay, so once again, let's try to formulate this problem, I mean this solution, in a more descriptive manner. What I'm saying is that how about I have some buckets. So for example, I have capacity 2 for this doubly linked list. Okay. Now what you do is I said that you want to add 1. I want to add 1. So it's the first thing when the function add will be called, what's gonna happen? It's gonna check the first bucket. There's a fixed bucket called first bucket. Okay. You check the first bucket. If the first bucket is empty or not, and it doesn't really matter. What you do is so first bucket is left, this, that, and right. So you add something to the first bucket, okay? And you have a hash map where you say that this key is corresponding to first bucket and this is the node, okay? So this is what happens when you add something and it doesn't really exist in the hash map. But if it exists in the hash map, then you take out the information, which is the bucket number, I mean the bucket and the node value. And now you say that inside of this bucket, I'm going to remove this node. So inside of this bucket, remove this node. Okay, simple. And you go to the bucket of higher level. How do you go to the bucket of higher level is you basically increase b by 1 and you get a bucket of higher level. And if it doesn't exist, then you get the default bucket and you add something there. Okay, and you add something there and it's simply done. Now we're done. Now someone says, so this is when you put, and when you get something, then you check if it is inside of this. Yes or no? No, then return -1. But if yes, then you check the bucket, which bucket it is. Okay, you check the bucket. And now since it has been accessed, remove it from this bucket and go to the next bucket and put it here. The same idea which we were doing here, we're going to do the same idea here. And all of this should be done in O of 1 ideally, because we are maintaining two hash maps, essentially two hash maps and one doubly linked list. And this is a better approach. I don't see a flaw in this approach right now. If I bucket things according to the counter, I really don't see a flaw right now. So how about let's try and do this using this particular method only. Okay, so let's try and write the code for this problem. Okay, so uh, definitely I'm gonna have count. Do I need to have count? I still need to have like buckets. Okay, what I'm gonna do is I'm gonna copy the code which is here in the remove and the init function. So I'm going to copy this piece of code. So I have capacity, I have left, right, I have this, I have edge, I have this, and I have this. Now let's try to make sense of all these things. Okay, so the first thing that I'm gonna do is for removing a node, I really do not need to know about the bucket. But when I'm trying to add a node, I need to have the information of bucket so that I don't take the self dot right of the wrong bucket. So how do I manage that? How about I have self dot bucket equals to an empty subarray, empty hash map. Okay, and this is something that we don't want here. Okay, let's have another function. Say define um, get bucket g bucket. Okay, or maybe get bucket is better. Let's say someone says that you need to get a new bucket. So you create left, right. Okay, you create left, you create right. Let's remove the self dot part from these two things because that's not necessary. Or should I say it's gonna create problems? Now you return left comma right. That's your bucket. Okay, this is how you have created one particular bucket. Okay, now you want to add something. So you need to know which bucket do I need to add. Okay, all right. And now you know the bucket. So you can simply say bucket dot right because bucket has a right. That's what a bucket is. Bucket has a left and a right. So what I should do is I should have a class, another class. Let's say bucket, and this will have this will have this won't take anything, and it's going to initialize a bucket like this. Okay, Even better if I can just copy paste this piece of code because it's gonna make more sense. Now it's fine. Okay. So this is gone. So now when you get the bucket, you know that the bucket has a right. Okay. And you know that the bucket has a left also. That's not the point. The bucket has a right. Okay. So instead of doing self.write, let's do bucket.write. All right. So this is it. Okay. Now let's focus on the get part first. So you're trying to get a key from the LFU cache. How will you do that? You will check. You will say if self.h.get key comma -1, right, is not equal to -1. In that case, you have the key, otherwise you just return -1. So when you have the key inside of your hash map, you can extract some information. You can extract the bucket, right? So these bucket can also have a bucket number, which is gonna be counter. Essentially, this is counter or maybe count. So we are going to say that this bucket is going to have count as count. Okay. Now I'm gonna say that I'm going to extract the bucket comma node from self.h of key. Okay, I'm getting a call, so I have to mute myself just a second. Okay. How do I mute myself though? I have no idea. Maybe I have to remove the audio input capture. That's the only way. Hmm. Okay, I'm back. All right, I'm back. Cool. So where was I? So I made some buckets. Now, if I inserted a key, let's say I found the key uh, inside of the hash map, so I can get the bucket and the node. Okay, and now I have accessed this one. So I'm going to take this one and I'm gonna remove it. So I'm gonna say self dot remove, and I'm going to remove this node. In case of removing, I really do not need the bucket, but so I've removed this node. I've removed this node. Now I'm going to add this node in the next possible bucket. So what I can do is I also need to have a this self dot buckets will contain all the possible buckets and stuff like that. So I also need to see this. I need to say that um, new bucket. Okay, my new bucket is gonna be self dot buckets dot get. Okay, self dot buckets dot get bucket, the original bucket, plus one, where the count is plus one, comma, by default I would just get bucket with the count, bucket dot count plus one. This is dot count. So this is how I will get the new bucket, and I'm going to add something into the new bucket. I'm going to say add something into this new bucket with the node. So this is simple. This is very trivial. And now I'm going to remove something from the or actually add something to my LFU cache. And when I'm gonna add something in the LRU cache, what I did is I had some conditions to check if the thing was there or not. So same thing I'm gonna do here. I'm gonna say self.h.get if it is already existing or not. Okay. So if this is not equal to -1, which means we already have that particular key inside of our LFU cache. And if we do have that key, then if we have that key, then what are we supposed to do? We're gonna take the bucket and node from that self.h key, right? So we extracted that. Now we have accessed it one more time, so we're gonna remove it. Self.remove node, right? We're gonna remove this, and we're gonna again find a new bucket. For this one, we're gonna find a new bucket, and we're gonna add this key. I mean this thing into the new bucket. And we have added this thing into the new bucket, so we also supposed to update this. H of key is now going to be a new bucket comma node, right? New bucket comma node. So it has slightly changed. Else if it was not there, if the key was never there, then in that case I just want to um, create a new bucket. Let's say just want to create a new bucket. Okay, just want to create a new bucket where the count is going to be 1, or I'm going to create a fake bucket with the count 1, or just get one of them, and then I'm going to add this node to that bucket. I'm going to say h of key is new bucket comma node, right? I'm going to say h of key is new bucket comma node, and here I'm going to check if self dot gap is negative, then I'm going to remove something. So this is what I did earlier. Delete self.h of self.left.next. Okay, so this time I'm gonna say my the left thing that I want is gonna be the it's gonna be self.buckets of 1. Self.buckets of 1 is gonna be my next. Okay, so I don't need to do this, and I can simply remove it, right? Okay, so this is something that should work if I can also figure out what to do with this bucket things, right? So I also need to update these buckets. So now let's focus on that. If someone gets something, and if I go here, then I'm gonna say, okay, every time I need to check, I need to sort of check. What do I need to check? I need to check if the bucket does not exist, then if the bucket isn't already there when I'm adding something. So a bucket can be there only when I'm adding something, right? A bucket can be there only when I'm adding something. When I'm adding something, then I can also go here and I'm gonna check if um, self dot buckets of bucket dot get bucket comma minus one. If this is minus one, like it never existed, then self dot buckets of bucket is actually this bucket. So here I'm gonna say bucket dot count is actually this bucket. Okay. So this is when you're adding something. Similarly, when you're removing something, then there's just one small check that I need to do, or maybe I do not need to do that, it's fine. Okay, so this has some problems. So I'm gonna remove this first of all. Let's see what's the next problem. Or so it says that node is referenced before something something. Well, yes, sure. So my node is gonna be list node of key comma value. Say h is not defined. I understand. I need to do self dot h here. It says bucket object has no attribute next. It doesn't, but you can. It definitely has an object left. Okay, so something happened, but we are always getting minus one. Okay, we are always getting minus one. This is possible only if you have. This is possible only if you have. If you never got the key in here, and you always add the key. You're adding the key when someone is putting something. You're adding the key into the edge. So edge should have the key, but edge doesn't have the key. Why it doesn't have the key? I'm adding the key here, and that's the case then. Hmm. 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 How's that not working? Says minus one. Okay. सबसे पहले we are putting some stuff, so let's print our thing. Let's try to print the edge itself. In the first part we put 1 and we put 2. In both of the cases we have two buckets, which is great, and then we someday put 3 also, but never mind. The point is, um, then we extracted 1 and it said that it returned minus 1. It wasn't supposed to return minus 1. um, it was supposed to return something else from here. It was supposed to return node dot value. Hmm. Let's see what is the problem now. Hmm. It seemed to work perfectly fine until one case where it says that I have one, but there was not, but we were not supposed to have one. Hmm. When did it happen? It happened when I'm trying to get one. In that case, one should not be found, but it was found somehow, which means when the capacity decreased, I didn't So when capacity decreased, I didn't removed it from edge somehow. How is that possible, by the way? Hmm. Can I print this? Can I print left dot next dot key and try to understand what are the things that are being deleted? 2 and 4 are being deleted. Is that how it's supposed to be? So 2 is supposed to get deleted, and then 4 is getting deleted, which is pretty weird. So 2 has been deleted. Then we insert 3. And when we insert 3, so 2 has already been deleted. Now something has been deleted. Let's also, okay, so now 2 has been deleted, and let's also say print self.h, right? 2 is the smallest, 2 got deleted, and we have 1 and 3 in our hash map, which makes a lot of sense. Now you got 3 once again, and when you say you got 3, you need to increase its value, right? You need to increase its value. So you put 3 again. No, you just got 3. So you got 3. So you remove 3 and you say new bucket, you get a new bucket, you inserted this thing, and you say that bucket dot count plus 1, you add some stuff, and you add this to the new bucket, and you say that I'm going to return the node value, right? Now when you go here, you're taking the buckets of 1 once again. Ideally, what I would suggest you to do is to take the bucket of minimum, self.min. How do you keep self.min? So initially self.min is 1, but when you're removing something, so you removed something, right? You removed on, let's say, when you're putting something and you remove something from here. In that case, when you have removed something, you need to check. You need to check before removing something. Maybe after removing something, you can check. What you can do is you have removed the left.next.k. So, hmm, so maybe this bucket can also have a small thing called self.key count, which is 0 initially. Okay, when you're removing, let's also get the bucket. So even when you're removing some stuff, let's give it the bucket. So wherever we have self.remove node, let's do this. Let's do this. So this is basically saying that when you're removing some stuff, then you decrease the bucket dot key count minus equals to 1. Otherwise you increase. यहाँ पे it's gonna create a small problem. It's okay, we tried hard. I don't think we can solve this problem on our own. So now we are going to check the solution. Hmm. hmm Okay, let's. अभी के लिए my brain has stopped working, so I'm gonna stop here. I'm going to stop here and I'm gonna say कि हम इनको चेक करेंगे पर बाद में करेंगे. अभी my brain has stopped working. So let's take a small break. Not actually small, let's take a big break. I don't know, this was the last stream for today maybe. If I'll try, so I'll try to solve a couple of questions off stream after this. And then I will stream tomorrow and कल से अच्छे से और शुरू करेंगे. बाकी आज के लिए इतना काफ़ी है. I'm happy with it. Um, I'm gonna I'm gonna go offline now and try to solve some problems if it's possible. So I'll see you guys. Thank you for tuning in and goodbye.